Okay, so today we're going to do 2011 an equilibrium question, and it's the question 1. So part A says that we need to find the charge of M out of MOH. I'm sorry about that. So then you do the swish-swish method and you should get positive 2. And part B, we have 3 parts, and in the first part you want to calculate the OH in the problem, and so then you would do your steps and do POH is equal to 14 minus pH. You plug it in because you're given the constant 19.5, and you would do 14 minus 19.5 and you should get 4.8. Once you've gotten 4.8, you put in the negative log of 4.8 and you should get 10 to the negative 4.85, which is also equal to 1.4 times 10 to the negative 5th. Once you've done that, you find the solubility constant, in which, since M and OH are gases, this is the only ones that you will use. So you would do M and a positive charge of 2, and you would have OH negative with an exponent of 2 on the outside, and make sure that you use the brackets. In part 3, you will find the value of KSP. So you should take M with the positive charge is equal to 1/2 of OH negative charge, which is also equal to 1/2 times 1.4 times 10 to the negative 5th molar, and you should get 7.0 times 10 to the negative 6th. After that, you need to find the value, and you would do the M positive charge of 2 times the OH negative charge with the exponent of 2, and this is what you should do. You should do 7.0 times 10 to the negative 6, which you found up here, and 1.4 times 10 to the negative 5th, which you found up here. And you should get 1.4 times 10 to the negative 15th. Part C allows us to just state which one is the most soluble, and MOH2 is molar solubility is equal to 1.0 times 10 to the negative 6. Forgot to put the M, but don't forget to put the M after that. You're given a constant for MCO3, which is 7.4 times 10 to the negative 14th at 25 degrees Celsius. Then you would compare, and you would have a difference of and the molar concentration of MCO3 is 2.7 times 10 to the negative 7, which then you compare and contrast to see which one is bigger. 7.4 times 10 to the negative 6 is greater than 2.7 times 10 to the negative 7. In saying that, the MOH2 has the greater solubility. For the last part, we are given the expression MCO3 solid makes MO solid plus CO2 gas. And in an equilibrium equation, we cannot use solids. So the only one that we will really be working with is the CO2 gas. For part 1, we will write the expression for partial pressure, for partial constant, and we will have PCO2. Also, because, as I said before, MCO3 and MO are solids, and we cannot have solids in the equilibrium equation. For part 2, we will put in we are given a constant for temperature at 423 K, and we have no change in delta, and we will use the given constant that you should know of 0.0821 and plug it in, and you should get 0.012 atmospheres. Once you're done with that, you should compare and contrast again and see which one, how to find the delta G. And this given equation, delta G is equal to negative RT ln K, in which 0.0012 is less than 1, making the K negative and the delta G positive. I hope you guys understood that, because if you don't, just ask me. This was Bre'Ana, just stating that, and yeah, see you guys later.